Hello, everyone, and welcome to my presentation. Today, I'm going to talk about intelligent cybersecurity analysis in IoT-enabled critical infrastructure. And I'm going to start with a slide to talk a little bit about myself, my research. I'm an associate professor in University of Calgary, and generally my area of research is focused on critical infrastructure security, IoT and OT security, and other AI-enabled techniques that we can use for security of cyber-physical system. We are located in Calgary, Alberta, which is one of the best university in Canada. We have approximately 30,000 students, and we will accept always PhD and MSc students who are interested in different fields of engineering. So I provided you my email address and my website information here in case you have any question at the end of presentation, or you're looking for a PhD or postdoc or master position, you can always contact me. So that's basically all about me. You can find more information in the website, definitely, if you're interested. And now I'm gonna start my presentation. So please let me know if you cannot hear me clearly, so I can stop my video in case it's basically making problem. Sometimes it happens. So far, it seems we're doing okay. I cannot see the comment actually, but I hope someone will read it for me if anyone has a problem. So I'm going to start with some explanation about critical infrastructure and Internet of Things. Generally, today's what we have in terms of critical infrastructure, which includes our healthcare system, our industry, our utility centers, and basically whatever that we have all around us, are example of cyber-physical system. Cyber-physical systems are basically tightly coupled communication network that have several embedded computing devices, smart controller, physical environment, and human that are interacting with each other. These type of systems are basically interacting with each other, collecting sensory data, sharing information, and communicating with each other to basically send appropriate control command. And that's the way that we basically manage our critical infrastructure through cyber-physical systems. So we have lots of interaction with IoT devices, Internet of Things devices. And basically, after Industry 4, the revolution that happens for the Industry 4, we see this cyber-physical system everywhere, all around our critical infrastructure and all the system that we are using. So they are basically combination of physical system and cyber components. Like physical, it's obvious what it means. The cyber component usually basically talks about the IT layer of the system, cyber communication channel, communication network that we have between devices. And this is something new compared to our old infrastructure, the architecture of our infrastructure traditionally. If I wanted to talk about a smart grid, which was basically if I want to talk about the power system, which nowadays we call them a smart grid as a revolution of the power system, those systems were designed like 100 years ago, where their main goal was to transfer basically energy, generate energy from one single location, and then transfer it to the home or other basically customer. So there was no assumption in mind that these type of system might communicate with each other. There was no assumption that there will be internet interaction. But nowadays, what we have is that we have lots of different components which are connected to each other. We have wind turbine, we have solar cell, we have distributed generation, and all other type of basically energy production system which are interacting with each other to deliver us in an efficient way the energy. And that means we need lots of communication network and lots of basically connection. So that changed our traditional power system to a smart grid, which is an example of cyber-physical system, and also our critical infrastructure. There are also other example, industrial control system are also example of cyber-physical system. So there are lots of them around us. And in terms of Internet of Things, this is also a network of physical objects or things that are embedded with electronics, software, sensors, and other devices. And it generally enables those objects or devices to collect information and share information with each other. In a broad way, we call them Internet of Things, but if we wanted to be more specific, we have industrial Internet of Things, which is more related to our critical infrastructure. It's like those devices which are specifically working in industrial environment, and also smart cities, another example of application of Internet of Things, because obviously without Internet of Things, without this interaction over internet and connection, we cannot have a smart city. So these are basically the technology that we are dealing with them. Cyber physical system, critical infrastructure, IoT-enabled critical infrastructure. So I assume that all of you know that there are lots of basically important reasons that we need to use this technology, because it makes our critical infrastructure more efficient. It makes the control of this highly complex and complicated system a lot more easier, and it's offer us lots of advantages. But it has also some technical challenges. I cannot say disadvantages. I would say technical challenges that we have to address before we can take advantages of this technology. One of the basically problem is with the interoperability, because we have different devices with different nature, and we wanted to connect all those devices together. So obviously we need different type of protocol, we need different type of communication network to be able to connect these devices together to have an efficient basically communication. And again, we need lots of network communication systems. That's also challenging to make sure how we change the architecture to match the cyber physical system. And also, if you just look at some statistics, you will see that the number of IoT devices or the number of smart meters or advanced metering infrastructure that we have, it's keep increasing. And some statistics shows that by 2025, I believe, we will collect almost 180 zettabytes of data. And there are some statistics that shows that at some point we will have a lot more devices compared to the number of basically human on the earth. So we have huge amount of data which are collected here. It's a good thing to have data, because obviously that will give us information and we can use those information to monitor our systems. But in the other side, how to manage these data, how to extract meaningful information from these data, this is also a challenge that we have to address. And one of the important challenges that we need to address is also security. Because as I said, when this infrastructure was developed like 100 years ago, no one was assuming that they will interact with each other. There will be internet interaction. There will be basically communication channel between them. The assumption was that they will work in an isolated environment, just will do their work and then basically transfer it to the other section. No interaction with the outside world. But nowadays, we're kind of rushed into digitalizing all this technology. We are pushing them to interact with the internet, and that basically raises lots of vulnerability issues. Because that means this system, they were designed without security in their mind when people were designing them. And that means there are lots of vulnerability and basically toward a different type of cyber attack. A third party can get access to this system through different channel, different pivot points, and then they can manipulate the system. So security is one of the important basically challenges that we have to address. Otherwise, we will end up with lots of catastrophic damages in the system. And today, I'm going to mainly focus in the challenges related to the security and how we can take advantages of the AI to address these challenges. So as I mentioned, we have increasing interconnection. We have an increased number of communication network, control systems that are designed 100 years ago and basically are not equipped with any security mechanism or tools. And we have two-way communication between devices and customers. And we have basically highly complex system compared to what we had before. And as I said, these can increase the risk of the cyber attack in the systems. I'm going to show you some example of cyber attack here. If we don't basically address this issue related to the security, we might end up having attacks like the one that happens in the Idaho National Lab in 2007, Iran Stuxnet attack in 2010, Ukraine attack, and other type of attack that happened recently in the US. So the problem is basically serious, and we need to take it serious. I also added another slide here that shows you basically more examples of the attack. If you're interested later, you can search about different type of attack and see basically how they created different type of damages in the system. These are all examples of attack that happened in critical infrastructure. And as you see, it mainly started with the Stuxnet, which happened in the Iran. And it was after that people were taking it serious, that such a type of attack can happen in industrial control system or operation technology. Before that, almost everything related to security was focused in the IT domain, information technology. And it was hard for the people to believe that such a complicated infrastructure, critical infrastructure, can be also affected and manipulated with the cyber attack. If I wanted to talk more about the cost or risk that are involved here, I can give you some numbers so you can add up this number, multiply this number to see how much is the cost when we talk about cyber attack in this sector, critical infrastructure sector. In general, the average cost per zero-day attack, zero-day vulnerability or attack, which means those type of attack or vulnerability which is basically identified by the attacker, but the organization itself is not aware of it. The average cost per day for this type of vulnerability is 40,000 up to 160,000. And the average number of days that those zero-day vulnerability will remain hidden from the organization is 151 days. Average number of days that it'll take to patch those issues, it's like that the organization will send someone to fix the issue and vulnerability, that's 120 days. So if you multiply these numbers, you'll see how many days and how much it will cost for the organization when there is a zero-day vulnerability exists. And also on the other side, you can see how many malware can be generated per day. Obviously, not all of them are new type of malware, malicious software, but definitely some of them would be totally new, which cannot be detected with the existing tools in the system. And once everything is basically detected, the patching and everything, the average dwell time, which takes the length of the time that the cyber attack has an environment and time to basically be eliminated, is taking almost 200 days. So it's like for 200 days, the organization might suffer from all these type of attack, and definitely the cost will be there. So if we don't take it serious by adding and multiplying this number, you'll see that there are lots of costs that can affect an organization if they don't take it serious. So the risk is there, and it's a really basically expensive one. If I wanted to talk more specifically about how serious the risk is when it comes to the critical infrastructure, I would say it's something here in the middle of this figure. I'm not sure if you can see it or not, my mouse. So it's not like at the stage that you can deny it, like nothing exists. And it's not like that you have to panic about it like the way that the media will does when a specific attacks happens, that you have to basically throw away everything and just focus in basically cybersecurity. It exists there. You have to be prepared for it, and you have to plan for it. So it's a reality. And another example that I can give you in terms of the vulnerability that is related to the critical infrastructure, the fact that it actually exists, is related to Urgent 11, which is a set of vulnerability which was detected by a security company in the US in 2019, I think. If you're interested, you can also search this and read about it, and you'll be surprised that how many vulnerability basically existed for many years for in the real-time operating systems in VxWorks, which was a real-time operating system, and it was used by many famous companies like ABB, Airbus, Boeing, and other companies. So it's like for many years they were using this operating system for their environment, for their OT environment, and they were not aware that there is some vulnerability with these operating system. And after a while, in 2019, a company basically did some research, and they found out that there are lots of vulnerability available, which means that there were lots of opportunity for the attacker, and obviously lots of attackers use those vulnerability to affect the system. So it's like the environment, it's new, and it's like some sort of playground for the attacker, and lots of people are not even aware of the vulnerability in the system. There are lots of basically investigation going on and lots of research going on to figure out what are the vulnerability or possibility for the cyber attack in this sector, critical infrastructure, I mean. A real example that we can also talk about is the attack that happened in the Ukraine. If you wanted to know a little bit more about how this type of attack can happen in a critical infrastructure. Obviously, it's not as easy as it happens in an IT layer, because for the IT layer, as soon as someone get access to an open port, they will basically be in the system. It means that they can have a successful attack if they pass basically, obviously, different security layer. But when it comes to critical infrastructure, physical systems, it's a lot more complicated than that, because we are actually talking about a physical component which needs to be changed, which needs to be manipulated. And it's not easy. We are also talking about very complicated and highly complex, basically, systems. And again, it's not like that the topology of this system is available for everyone, that they can figure out where each switch is located, where each bus is located. It's not easy. So for this type of attack, it's like attacker has to bypass many layers, and they have to remain hidden in the system for many months. In the case of Ukraine attack, they were in the system for 6 months, and they were collecting different type of information to be able to figure out what's the topology of the system, and then basically execute their attack. So what happened in the case of Ukraine, which was in winter of 2015, was that the attacker started with phishing email, and they basically were successful to get access to a high-level IT credential through the phishing email, and then they used that credential to get basically privileges and access to the system. With those access, they used VPN connection to remotely connect to the system, install their malware. And once they installed the malware, it was like they could have some sort of remote station for themselves to take control of the system. And then they were able to launch different type of fault, open and close different type of switches in the system, and know the system very well. So as I said, for 6 months, they were manipulating the system, they were collecting information, and no one was aware of it. If you look at the forensic report, which is there available for the Ukraine attack, you will see that lots of engineers reported that there were suspicious activity in the system, like there were faults in the system, and then when they were sending crew to fix those faults, they noticed that there is no actual fault in the system. So there were attackers who were manipulating the system to figure out how employees or how engineers would fix those type of fault. So they wanted to have plan, to be prepared to cause as much as possible damages to the system. And after a while, when they collected enough information, they were even managed to get access to the basically internet and telephone. So they also had the denial of service attack in the day that they launched their attack, and they managed to have three basically simultaneous attack in three different substations, which left almost 225,000 customers without powers for several hours during the winter and in the middle of the night, which you can assume that it can cause lots of damages to the economy and lots of fear for the people. And unfortunately, actually, they were not prepared for it at all. And even when the attack happens, again, if you search a little bit more about the Ukraine attack, you will see there are some videos recorded at the time of the attack. And all those engineers were doing was that they were recording their monitor, because they were not even clear that if it's what's happening. Is it a cyber attack? Is an IT department manipulating the system? They didn't have any mechanism to at least prevent the propagation of the attack in the system. So they were just recording video to show that it's not me who are opening and closing these switches. It's not me that I'm basically causing damages to the system. They were not prepared about it at all. And it's I don't know, it's kind of funny or sad, but again, the next year after this, in 2016, there was another cyber attack in Ukraine that happened in another utility center. So that shows us that even if we wanted to be prepared for this type of cyber attack, it needs lots of time. So even after a year after this specific attack in 2015, they were not prepared enough to prevent another catastrophic damages in their utility center. So we need lots of time and basically huge amount of research to be able to be prepared for this type of attacks in the system. In terms of the solution that already exists, you might ask, obviously we have lots of solution. Why we cannot use them for this sector, or how this basically solution works in this environment. If I wanted to give you a general view, it's like what we have right now is, in terms of the security solution, is like we're adding just more wall to the system. That's basically what we have in terms of the existing solution. But the problem is that when it comes to critical infrastructure security, it's like that we are putting a gate in an open environment by adding more wall to the system. Because what we do in terms of the IT layer security, it's like that you will add more walls to the system. You wanted to protect your system, but it's like that you have strong walls, but someone will leave the door open. And that means an open point or access point for a third party to get access to the system. That's basically what happens in terms of the critical infrastructure. We have a strong IT layer security, but at some point, somehow a door is open, and then the attacker will get access to the system. And unfortunately, we don't have any active solution when it comes to monitoring the behavior of the system, basically after those walls are passed. So that's why we need different type of solution for this sector. Sorry. And if I wanted to look more specifically in the solutions that are available in the IT domain, I can talk about basically antivirus which are available, customized password, secure programming, or patching the devices, because these are basically main type of solution which is available in IT security domain. And some of you might say that, okay, compared to the IT, we don't have that many users in this sector, so it should be easy. We will just install antivirus in all of the software that we have there. We will make customized and complex password, and we will use secure programming, and we will patch our devices regularly. That will solve the problem. Why we need to develop new solution at all? But it's not going to work that way, actually. Unfortunately, all of these are basically wrong when it comes to the security of the OT, operational technology, which is related to the critical infrastructure. And I'm going to talk about it in the next slide, why I'm saying it's not working. First of all, if we wanted to talk about basically antivirus, I would say when we talk about critical infrastructure, we are talking about very, very expensive basically infrastructure and devices. And most of the time, what happens in reality is that the vendors of those basically infrastructure, they won't allow a third-party scanning. For different reasons, they won't allow scanning. And so if you put yourself in place of a owner of a multi-million-dollar basically infrastructure, you're not going to jeopardize it to scan it with the antivirus to lose the warranty, because that will cost a lot if the device is damaged or whatever happens to it. So lots of time it's not possible to do it because of these financial reasons. And besides that, even if you basically use antivirus to check those basically infrastructure, you'll see that the antivirus is only able to scan the basically the Windows portion of the system. They're not able to scan the basically OT layers of the system if any component is related to the operational technology, basically part of those infrastructure. Only the IT layer, the Windows layer, can be scanned through antivirus. So still, if we have some vulnerability in other layers, those layers are hidden from the antivirus. So it's not going to work, obviously. And we cannot also use a strong password here. And unfortunately, again, what happens in reality, if you basically visit different sectors, you'll see that they don't even change the password at all. They usually use the default password. And again, the reason is that lots of different people are using this infrastructure. So if you change the password, you're kind of jeopardizing the real-time operation of this system. Someone might forget the password, they might end up resetting the system. And even if you make the password complex, sometimes people make even more a rookie mistake. They will put the password somewhere which is obvious, anyone can see the password, just to avoid forgetting the password and delaying the performance of the system. So again, it's not going to work if you just wanted to make the password customized or give access to a specific number of people, because there are lots of people are using this system. And as I said, you cannot jeopardize delaying the operation of these systems. So it's not going to work. Secure programming is also difficult by itself. And the other things that usually helps in the IT domain is the regular or automatic patching to figure out for vulnerability and fixing the vulnerability as soon as they arrive. But again, it's not going to work for the basically OT sector. And the main reason is that when it comes to the OT, critical infrastructure, we have lots of small components which are connected to each other. And it's like that you have a device, hardware is coming from one company, the software is coming from another company, code is coming from another company, and lots of different companies are involved here to give you that piece of device. When a vulnerability happens, no one takes responsibility. You don't know who's responsible for patching, who's responsible to basically check if there is something wrong for the specific device. So you cannot have basically regular patching by vendors, because it's not clear who's the right person to reach out. So you might say that, okay, we're going to go with automatic patching, just regularly every hour, every month, or whatever, patch the system. But it's not also possible because, as I said, since the nature of this system are very complex and complicated, if you, obviously when you do patching, you might reset the device and you might basically have to stop that specific device from working. But you have no idea how many other devices are connected to that specific component. So you might basically delay the operation of the whole system. When it comes to the IT, it's not a big deal. You just lose internet for a few minutes or a few hours. But when it comes to critical infrastructure, just imagine stopping the utility center from working, or an oil and gas, basically pipeline system from working. You cannot do it. You cannot do it even one per month. What about every day or every week? So there is lots of cost, and because there are different priority when it comes to the IT and OT, we cannot use these basically existing solution. In the OT, what we have is that we wanted to make sure that everything is available all the time. We wanted to make sure that our service is available. But when it comes to the IT, we mainly wanted to make sure that confidentiality is preserved. So the priority is also different. And that's why we cannot use the solution. You can also do some more research, and you'll see that there are lots of other basically reasons that we cannot use this technology. And the reason is that we have a specific gap between IT and OT. So it's like IT is covering a specific area, OT is covering another area. But right now, with cyber physical system, we are connecting these two domains, but still there is a gap in between. The relationship is kind of adversarial. So if you look at the organization, you will see that when it comes to the security, most of the budget will go to the managerial level or later to the IT department, but we don't have that much of a budget that goes to the engineering sector, which is related to the OT, and what we have the gap right now. So there is an adversarial relationship in terms of the OT and basic versus IT, what we have available. There are also other problems related to the gap in this area. It's like that these two departments, OT and IT department, in most of the organization, they are not aware of each other's situation. Like IT take care of everything in terms of the security of the basically cyber component in the system, but they're not aware that their engineers actually using a specific laptop which is not secure. So that engineer will take the laptop in the field, and that means a pivot point for the attacker. So because we have a gap here, we have an adversarial relationship here, we cannot just put everything on IT's shoulder to take care of the security of the system. We have to address the gap. We have to connect these two sectors so they will be more interaction, they will be different view, which is combined with each other, and then we can have some sort of hybrid type of solution, combined type of solution that can be used to address all these problems. It's not something that can be addressed solely by IT department or by OT department. We need to combine these two departments. So to address this problem, we can have this type of different type of basically solution. We can have short-term solution, medium-term solution, and long-term. In terms of the short-term solution, what we can do is to provide some incentives, maybe for the vendors, so motivate them to regularly patch their devices, provide different basically patches to address the vulnerability and solution like this. But obviously, it's not going to be something that fixes the problem. It's just something that alleviates the basically damages for a short period of time. For the medium term, we can take advantages of basically intelligent technology like AI, big data, and this type of technology to develop tools that can take advantages of all available data to monitor the performance of the system, to give us a heads up, and at least we will have some sort of time before the catastrophic damages or cascading failure happens, and we can basically take care of it to protect the system from further damages. It's hard to prevent the damages, basically to reduce the cost to $0 maybe, but at least we can prevent cascading failure in the system. But obviously, for the long-term solution, we need to have resilient type of systems, specifically estimation and control algorithm, to basically make those systems resilient toward cyber attack. And we have to make those devices which are used in this sector secure by design. So we have to add security in mind when we are designing this basically infrastructure. And obviously, it's not something that can happen in a short period of time, because we're talking about large-scale critical infrastructure, and these systems are expensive. You cannot just shut down the whole system and build it from scratch. It's like layer by layer, you can basically upgrade this system, and it takes time. Eventually, we will be there, but it will take time. In my research, I mainly focus in the medium and then long-term basically approaches. And today I'm going to give you some example about the work that we did here to give you a general idea how we can use basically AI for security of critical infrastructure. So as I said, we wanted to take advantages of AI for the security analysis. You might basically think why we wanted to use AI if you're not basically familiar with the power of the AI and the nature of the security problem. But the main reason is that basically you can see AI everywhere nowadays. Wherever that you will look, in the energy sector, in the utility sector, in the military, I don't know, in the stock market, in the aviation system, in the health system, wherever you look, you'll see that AI is somehow involved. So there are lots of power for this technology that we can take advantages of it. We were not able to use it maybe 10 years, 20 years ago to this extent because we didn't have enough storage power, we didn't have enough computing resources, and we didn't have enough mathematics basically available to be able to take advantages of AI. But nowadays, we have all these three components, and that's why everyone is trying to find a usage for this technology. And obviously, we can take advantages of it when it comes to the security analysis. So I'm going to talk a little bit more about what we call actually an AI system. To have a system which we can call it artificially intelligent, the system needs to have four components. First of all, it needs to act like human. It means like, and that's something that you can assess it with a test which is called Turing test. It's like that if you put a basically human questionnaire in a room, and in the other side of the room, if you put a computer, that human being cannot say that if computer is answering his or her question or basically another human is answering the question. It's like that system that can act like human. This is a component that we need to have for an AI system. Another component that we need to have basically for an AI system is to have a system which thinks like human. Acting like human is something, but thinking like human is another thing, because that involves cognitive science, what's behind our brain and the way we are thinking, which is not something easy. You might be able to build something, develop an algorithm that can act like human, but it's a lot harder to build something that can think like human. So that's also another basically criteria or characteristic that we have to add for our system to be able to call it an AI agent. Another property is to have a system or agent that can think rationally. Lots of things that we do as human in our life are rational, which is defined in terms of different logic. But obviously, when you use logic, you cannot express everything. So sometimes it's really difficult for us to basically explain what we are doing, why we are doing such a things. And again, modeling these things for a machine, to have a machine that thinks rationally, this is also something difficult to achieve. But we need to have this to be able to call it the AI agent. And finally, we also need to have an agent that acts rationally. So again, rational behavior most of the time means that we're doing the right things. But as a human, lots of times we might do something which we call it the right things, but it does not involve any profit for us. When it comes to the AI agent, we usually have to define something in terms of the profit for the agent. That's what the agent understands, that it has to increase the profit. It has to decrease the basically damages in the system. But honestly, if you look around, you'll see that lots of time we do some things that even might damage us, but we think it's the right thing to do. And again, developing such a knowledge for a machine is something difficult. So think like human, act like human, think rationally and act rationally. We need to have these four components for an AI agent to call it an actual AI agent, which is honestly more abstract for now. And if you look at the basically evolution of the AI, you'll see that the idea of the AI was developed in around 1950, but still we cannot call our system AI-enabled system. what we are doing is using subset of AI actually. Still, achieving all those 4 criteria is an abstract idea, and we're far from it. So what we're using right now is more like machine learning and deep learning. That's when we call about AI techniques, we're mainly talking about machine learning and deep learning, which are subset of AI. And that's what I mean. In terms of the machine learning and deep learning, I assume that majority of you are familiar with it. When it comes to the machine learning, we basically wanted to develop different type of algorithm, which could be like supervised type of algorithm, unsupervised type of algorithm, or reinforcement type of learning, which will help a machine to learn how to basically behave in a specific scenario, how to categorize in a specific type of data, how to classify a specific type of data. It's like compared to the traditional programming, when we fed the data to the system and we will get the algorithm. In the machine learning, we will fed the basically input and output to the system, and we wanted to get the algorithm. In traditional programming, we have the algorithm, but when it comes to machine learning, we wanted to get the algorithm out of it. We wanted to see how a machine can think or behave or learn basically a specific pattern in the system. Deep learning is also a subset of machine learning, but there are some differences between these two. And one of the main differences is that when you wanted to train a machine, you have to feed the machine a specific features type of data set. So the machine will use those features to learn a specific basically behavior. But when it comes to the deep learning, you will remove that layer and you will feed all the data to the agent, and the agent will basically shuffle around the data and go back and forth to extract a pattern. So compared to machine learning, we need more hardware dependency because we're dealing with more data. It will take more time, and in terms of the difficulty of the solution, when the solution is when the problem is highly complicated, usually deep learning will help us better. So there are some overlap between these two technologies, but there are some changes, and depending on the nature of your problem, the size of the data that you have, the limitation in the time, the execution time, all of these, you can decide which one is the right one for you to use. For the cybersecurity, also, we can use AI and machine learning in for different parts. We can use it for triage to augment the rule-based detection system that we have using machine learning. We can use it for threat hunting, which is some sort of active, basically searching in the environment to actively search for abnormality in the system, any abnormal behavior in the system. And that way, when we have an AI agent, when we have a machine learning or deep learning model, it can continuously go through the data, figure out what's wrong or what's suspicious in the data set, and gives us a heads up about that suspicious activity might be a basically sign of cyber attack. We can also use it for incident analysis. When an attack happens, obviously you have lots of information collected, and it's difficult for a human being to analyze all those information and see what was wrong, how these are related to each other, how to find the source of the attack or analyze the incident to prevent further basically damages for the system. This is also where AI can help us. And another domain could be like incident response. We can develop a decision support system to help the basically security analyst in terms of responding to an incident. Like those systems can be used to give a list of proper action to the agent, and then the agent can choose between those action basically to mitigate the effect of cyber attack in the system. So there are lots of different basically domain that you can use AI for security. I'm going to give you some example of the work that we did here. One of the work that we did was using it was developing actually an unsupervised cyber attack detection system for a smart grid. We had a smart grid model for a power system and a smart grid model. And for that, what we did was we were trying to decompose our system to different subsystems. And we used a Markov model and restricted Boltzmann machine to model the behavior of each of these subsystems in a way that can gives us a heads up or predict the future behavior of that specific subsystem, like a state of subsystem. What would be the voltage magnitude, the frequency, the angle, and all this stuff. These are signs of changes, sudden changes in the system. And then we used some statistical analysis to figure out what is the statistical difference between these two different components of the system, different basically layer of the data that we had in the system. And we noticed that when an attack, like false data injection attack, happens in the system, we can basically categorize the nature of our data into two parts. One of them was normal, and the other one was abnormal type of data set. And that way we could figure out if there is an attack in the system or not. In another work, we use representation learning, which is basically a subset of deep learning. And with the representation learning, what you do is that you will shuffle around the data. You will look your data from a different perspective, and that will let you basically get more information out of your data set. With the representation learning, also, we noticed that if we add this layer as a preliminary layer to all other basically deep model or machine learning model that we were using, that will basically improve the performance of the system. In another work, we developed a threat hunting and attribution system when we had basically two-level, three-level system. First, we developed one class classifier to detect if there is an attack in the system. And then once we detected attack in the system, we fed our basically data set to another deep model to be able to narrow it down to a specific family. Because it's very important when you detect the attack in the system to figure out which family the attack belongs to. That's also an important and difficult and challenging things to do that deep learning could help us to basically work with it. Another domain that we used this was for location identification, which is also important. When you detect the attack, it's important to figure out which specific location of the system is damaged, because otherwise you're dealing with a very large scale system, and that's very difficult basically to fix the problem. Another domain that we used was for the fault prediction, to figure out if a fault is basically make the system unstable or not. That's also another way that you can use AI or machine learning. We also used it using a for the state estimation problem to predict the future behavior of the system from the historical data set that we have. And overall, we're trying to basically use our develop approaches that are multi-view and multi-layer. We are trying to collect data from different basically perspective and layer in the system, both physical data and both cyber data in the system. When you combine these two layers, you will get a lot more information from it compared to the traditionally looking at one single view in the system. And again, developing this type of data set is something challenging, and analyzing this data set, extracting meaningful information out of this data set is also something challenging, which is possible with the basically power of the machine learning and AI. So overall, what we wanted to do is to develop something like a security and event management system that we have in the IT domain for the OT domain. You can find more basically in terms of the research that we are doing in my lab to see what type of solution that we developed. One example, which I think we don't have that much time, but one of the examples that I wanted to talk about was the solution that we are developing for a smart grid. You can find more information about it, which is an example of the SIM solution that we developed for basically a smart grid, which has detection component, which has hunting component and attribution component that can be fully installed in a smart grid system and analyze the performance of the system to give you a heads up if there is an attack in the system. If an attack is there, what type of, what family the attack belongs to, and how we can come up with a perfect solution to deal with the basically incident that is happening. So these were examples of AI and machine learning basically usage for the security analysis. And you can basically do a lot more with it. But what you should have in mind is that when it comes to taking advantages of AI, there are also challenges. It's not like this will fix everything for us. You have to be careful to address those challenges as well. It's like that one challenge is having enough data. Compared to other sectors, when it comes to critical infrastructure, we still lack enough data sets and proper data set to be able to do this analysis. So lots of time you might end up developing this data set in the lab, but still it's a challenge. The reliability of the algorithm that we developed should be improved, because otherwise we will basically have AI agent which can be attacked by another AI agent through the attacker. We need to take care of the privacy of these basically AI engine that we develop. We have to be careful about the privacy of the data that we use, and also we have to be careful that using AI is also controversial. So we have to be careful about ethics of AI. If I wanted to talk more about privacy, I would say that lots of time people make a mistake in terms of the security and privacy, and they mix these two concepts. When we talk about privacy, we means that we wanted to prevent unwanted transfer of information. But when we talk about security, we wanted to talk about protocol and primitives that basically distinguish malicious activity. So when we are using AI technology, we have, for security purposes, we have to be careful to address the privacy of the data. One example could be like different smart metering devices that we are using in the field. And right now, the way that we are using these devices is that everyone can access the information. It's like the vendor can access, the customer can access, the utility center can access. So it's like there is no privacy preserved. The data is available for everyone. Obviously, we need these data sets to be able to develop our AI solution, but we have to think about privacy techniques like data masking, data anonymization, and all this stuff to preserve the privacy of the data. So we have to be careful about both of these two. And finally, AI is controversial by its nature, and lots of people already raised concern about using AI. If you look at the basically different experience that is reported in the news, you'll see that there are lots of different techniques, like the chatbot that was developed by Microsoft, which ended up basically having a bad performance, root performance, and then Microsoft basically deleted it after a couple of hours. You find a lot more example like this that shows that people developed a specific technology for a specific purpose, and they ended up seeing that it's basically misused, that specific technology. You can also, as another example, you can also look at Google Translate. If you search some specific keyword in Google Translate, you will see that for some language which is gender neutral, like our language, lots of time you will see gender bias in the translation. If you translate like he's a doctor or she's a nurse, actually, if you type doctor است, Google will tell you he's a doctor. If you type it پرستار است, Google will translate for you she's a nurse. So you can use lots of different examples like this, and you'll see the obviously a gender bias here. And obviously, it doesn't mean that basically Google's engineer wanted to add this gender biasness to the technology, but it's there because they were not thinking of it. They were not basically aware that the technology might be misused. There are other examples that you can find in the literature, and you'll see that lots of times technology is developed for a specific purpose, but it's being misused. And the same things might happen for the security analysis. So we always have to be careful and make sure that what we are developing cannot be misused. We have to basically study the ethics of what we are doing, how it can be misused and manipulated. That's also something we have to keep in our mind all the time. And at the end, I have again one slide here for you in case you need information, basically to reach out to me. And I would like to thank you all.